Bismillahirrahmanirrahim. Assalamualaikum class. Today we are going to start the Eliey-Rideal mechanisms. The Rideal mechanisms for heterogeneous catalytic reactions. So according to this mechanism, according to Eliey-Rideal ER mechanisms. According to this mechanism, one of the reactant react in absorbed form. According to this mechanisms, one of the reactant reacts in adsorbed form, while other second reactants reacts in fluid phase. For example, we have a reaction that is A in the gaseous phase plus B in the gaseous phase and gives the product at the surface of the catalyst. So according to ER mechanism, reaction proceeds in two steps. First, one of the reactant, let's say A, get adsorbed at the surface of the catalyst. Then B react with A in adsorbed form. And A is in adsorbed form while B is in the fluid form and gives the product. So this process can be broken down into following steps. Can be represented it can be represented in steps, can be represented as A in the gaseous phase move toward the surface and get adsorbed. Then A in adsorbed form plus B in the gaseous phase, it gives the product in adsorbed form. And then B in adsorbed form desorbs and move away from the surface of the catalyst. So Kr is the rate constant for this reaction. So rate of reactions depends on A adsorb and pressure of the B. So we can write as rate is proportional to A in adsorb form and rate is proportional to pressure of the B. So combining these two equations, we get the rate expression become as rate is proportional to A in adsorb form and B pressure of the B. So A in adsorb form, it can be represented KR, A adsorb and pressure of the B. A in adsorb form can be expressed in terms of fractional surface coverage as in Eliey-Rideal mechanisms. Can be expressed in fractional surface coverage. Fractional surface coverage, that is theta. So we can write R is equal to KR theta A and pressure of the B. So theta, fractional surface coverage, can be expressed in terms of adsorption isotherms. Different adsorption isotherms can be used. Most commonly used one is the Langmuir adsorption isotherms. So according to Langmuir adsorption isotherms, if both adsorbed इस केस में एक ने एड्सॉर्ब फॉर्म में रीड करना है, दूसरे ने फ्लूइड फेज में। अब ये ज़रूरी नहीं है कि बी ने एड्सॉर्ब नहीं होना है, ये भी पॉसिबल है कि दोनों एड्सॉर्ब हो रहे हैं, लेकिन बी ने एड्सॉर्ब फॉर्म में रिएक्ट नहीं करना है, उसने रिएक्ट करना है फ्लूइड फेज में। अगरचे ये भी एड्सॉर्ब हो सकता है सरफेस पर, सरफेस इज अवेलेबल, सो इट कैन बी एड्सॉर्ब, हाउएवर इट रिएक्ट इन फ्लूइड फेज। तो अब अगर दोनों एड्सॉर्ब हो रहे हैं, लेट्स सपोज एक कंपेटिटिव एड्सॉर्प्शन है, then theta A will be equal to APA 1 plus APA and BP of B. So rate equation become as KR and A pressure of A 1 plus APA plus B and PB and pressure of B. So this is the rate expression for surface catalyzed reaction according to ER mechanism, according to Eliey-Rideal mechanisms. This one is rate expressions for surface catalyzed reactions in terms of ER mechanisms. If B is not adsorbing, B is not adsorbing species, then the rate equation would be, and इस डिनोमिनेटर में से P भी खत्म कर देते हैं, तो simple we get R is equal to KR AP of A 1 plus AP of A and pressure of B. So this is the rate expression for surface catalyzed reactions between reactant A and B in terms of ER mechanism, in terms of Eliey-Rideal mechanisms. When pressure of A is low, when adsorption of A is weak, we have different cases. Number first, when pressure of A is low, R, adsorption of A is weak, then 1 plus APA will be equal to 1. So we ignore APA in comparison to 1 in denominator. So we get the right expression is KR APA divided by 1 and P of B. So this is R KR APA and P of B. R is equal to K apparent, P of A and P of B. So this is a second order equations. Second order equations. If pressure of A and B is same, if P of A is equal to P of B and this is equal to P, then we can write as R is equal to KAP and P square, R minus dP by dt is equal to KAP and P square. It can also be written as minus dP divided by P square is equal to K dt. अब अगर इसको इंटीग्रेट करते हैं, so we get 1 over P T is equal to 1 over Pi and plus Kt. So this is a second order equations. Pi is initial pressure and Pt is the pressure at different time interval. T versus 1 over Pt अगर plot करते हैं, so we get this type of graph. So इसका slope is equal to apparent rate constant. So when pressure of A is low, R, when A is weakly absorbed, then the reaction follow the second order kinetics. Alternately, when pressure is high, at high pressure, when pressure of A is high, then APA 1 plus APA will be equal to APA. ये इस इक्वेशन में लगा लेते हैं. Then we get is rad is equal to KR APA APA and P of B. So this equation is KR and P of B. So this is first order with respect to pressure of B, and it is zero order with respect to pressure of A. At high pressure of A, rate is independent of pressure of A. Rate does not depend on the pressure of A. So rate does not depends on pressure of A when pressure A is high. So it is zero order with respect to pressure of A. Similarly, if B is kept constant, इक्वेशन है हमारे पास इस इक्वेशन में, ये रेट इक्वेशन है, इसमें अगर B को कांस्टेंट रख लेते हैं, if pressure of B is kept constant, then how rate varies with the pressure of A. हमारे पास फिर रेट इज इक्वल टू के आर पी बी ए पी ए एंड 1 प्लस ए पी ए, ऐसा हो जाएगा. अब ये कांस्टेंट है. सो व्हेन ए इज वीकली एब्सॉर्ब्ड, when A is weakly adsorbed, or when pressure of A is low, then 1 plus APA will be equal to 1. So we get R is equal to KR PB A and PA. ये सारे कांस्टेंट कंबाइन कर लेते हैं, so we get KAP and PA. So this is a first order equations. First order. Rate is equal to minus dPA divided by dt is equal to KAP and P. Rearrange करते हैं, minus dPA divided by P is equal to KAP and dt. Integrate करते हैं, minus dPA divided by P is equal to KAP and K dt. So we get minus log of Pi and Pt is equal to K apparent and T. इंटीग्रेशन हम पहले कर चुके हैं, तो इस डिटेल में नहीं जाते. तो दिस इज अ फर्स्ट ऑर्डर. T versus log of Pi divided by Pt gives a straight line, and slope is equal to K apparent rate of. Similarly, for strong adsorption or when pressure is high. When P of A is pressure of A is high or A is strongly adsorbed while B is kept constant, then what will be the rate expression for surface catalyzed reaction in terms of Eliey-Rideal mechanism? So in this case, rate is equal to KR APA KR P of B and APA or 1 plus APA. So pressure is high or it is strongly adsorbed. So 1 plus APA will be equal to APA. So we get rate is equal to KR P of B APA and APA. इससे 1 आ जाएगा और ये कांस्टेंट है, so R is equal to K apparent. So this is zero order. Zero order यानी किस कंडीशन में? When pressure of A is high and pressure of B is kept constant, then this is zero. This follows the zero order kinetics. When pressure of A is constant, A is high and B is not constant, then the reaction is first order with respect to B and zero order with respect to A. लेकिन अगर एक को कांस्टेंट रखते हैं then the overall order reaction is zero order reactions. और इसके लिए ये हम लिख सकते हैं minus dPA divided by dt is equal to KAP or minus dPA is equal to KAP and dt. इंटीग्रेट करते हैं is equal to KAP and dt. तो ये इंटीग्रेशन हम पहले कर चुके हैं. It gives PA is equal to PI minus K apparent and T. This is for zero order equations. Zero order. and अगर हम T versus PA को plot करते हैं, so get this equations. This intercept is PI, initial pressure of the A. So ये तो हम लैंगमियर की टर्म्स में एडसॉर्प्शन को डिस्कस कर रहे हैं. जिस तरह एलिज मैकेनिज्म में हमने डिस्कस किया था कि एडसॉर्प्शन may takes place according to any of the adsorption isotherms. तो इस तरह इस केस में भी पॉसिबल है कि कोई भी adsorption isotherms applicable हो सकता है. Then we have different types of rate expressions as rate is equal to Kr theta A and pressure of B. So theta A can be expressed in terms of Langmuir adsorption isotherms, in terms of Freundlich adsorption isotherms, in terms of Temkin adsorption isotherms, and so on. If adsorption of A follow the Freundlich adsorption isotherms, if adsorption of A follow the Freundlich adsorption isotherms. Freundlich adsorption isotherm है theta is equal to K P1 over n. तो ये वैल्यू लगा लेते हैं. Then we get R is equal to KR K P of A in 1 over n and pressure of B. Similarly, if adsorption follow the Temkin, so according to Temkin, it is the theta, fractional surface coverage theta, is equal to K1 log of K2 and P. So the red expression will be equal to Kr K1 log of K2 and pressure of A and pressure of B. So we have different types of red expression depending upon the adsorption isotherms. So this is about the Eliey-Rideal mechanisms. अब इसमें एक ये पी बी गैसियस फेज में है, ये भी पॉसिबल है कि एक गैसियस फेज में हो और दूसरा लिक्विड फेज में हो। अगर लिक्विड फेज में है तो फिर यानी A in the gas phase plus B in liquid phase and gives the product. Then the red expression will be red is equal to Kr, और इसमें से let's suppose A adsorb हो रहा है, तो theta A and concentration of B. For liquid phase reactions, red depends on concentration. For gaseous phase reaction, red is proportional to pressure. तो फिर concentration की term यूज कर लेते हैं और वो डिफरेंट एडसॉर्प्शन आइसोटर्म यूज करेंगे। इसी तरह अगर बी ने एडसॉर्ब करना है, so red is equal to Kr theta B and pressure of A। जिस तरह ये सारा हमने डिस्कस किया है, उसमें हमने क्या है कि A को एडसॉर्ब while B react in the fluid phase। अल्टरनेट भी पॉसिबल है कि A ने फ्लूइड फेज में रिएक्ट करना है और B ने एडसॉर्ब होना है। इट डिपेंड्स ऑन पोलैरिटी ऑफ द रिएक्टेंट A एंड B, कौन सा इजीली एडसॉर्ब होगा, उसने एडसॉर्ब होना है जो नॉन पोलर होगा, या एडसॉर्प्शन कैपेसिटी एडसॉर्प्शन पॉसिबल नहीं है तो उसने फिर फ्लूइड फेज में रिएक्ट करना होगा। एग्जाम्पल पर हम नेक्स्ट डिस्कस करते हैं डिफरेंट एग्जाम्पल्स रिसर्च पेपर से या जो रिपोर्टेड एग्जाम्पल है, उसके काइनेटिक इक्वेशन क्या होंगे वो हम फिर नेक्स्ट डिस्कस करते हैं।